In session 68, we're going to be factoring the difference of two squares. Remember, difference indicates that it's a subtraction problem, and what it's indicating is that you have an algebraic phrase where each of the two components are squares themselves, that there's a very straightforward way to factor that. So if we have a certain number a and it's being squared and we're subtracting from that another number that's different, we'll call it b, and that's squared, that factors into a plus b times a minus b. And just to show you how that works, once again, it's the distributive property. Distributive property is crucial to factoring. We start with our first term. A times a would be a squared. Then we take our a times our second term, and a times a minus b is a minus ab. So that takes care of our second term. Now we're going to take both terms multiplied by our first. We're now going to take our second term b and multiply it by our first one there, and then also times our second one. What is b times a? It's a plus ab. And then b times a minus b is a minus b squared. What happens to this minus ab and this plus ab? They cancel each other out. That minus is canceled out with it. So what's that leave you? A squared minus b squared. So we can see a plus b times a minus b. These middle terms, the minus ab and the plus ab, cancel each other out, leaving you with simply a squared minus b squared. So let's take that a step forward here and solve a very basic problem. X squared minus 121. Well, is our first term, our first monomial, is it a square? Yes, it is. X squared is the square of x. What about our second term, minus 121? Is 121 the square of anything? Yeah, it's the square of 11, because 11 squared is 121. So we could just as simply rewrite this as x squared minus 11 squared. Now we just simply use from our previous screen, our factor statement. A squared minus b squared is going to equal a plus b times a minus b. So there's our a squared minus our b squared. In this situation, x squared represents the a and from our previous statement, and the 11 squared represents the b. So how do we factor this? We're going to have two terms here. Our first one is going to be an x here. This is positive, so we're going to have a positive here as well. And then for our second term, which is our difference now of two squares, it's being subtracted, we're going to have a plus 11 on one of them and a minus 11 on the other. So if we were to multiply that out, x times x is x squared. X times minus 11 is minus 11x. 11 times x is a positive 11x, so the positive 11x and the minus 11x cancel. And then our 11 times a negative 11 is a minus 121. That gives us what we started with, x squared minus 121. That then is the factorization of x squared minus 121. Let's take a look at another one here. X to the fourth minus 25y squared. Remember, in this lesson, we are factoring the difference of two squares. So what we need to identify are each of these two monomials squares, squares of something. Yes, x to the fourth is the square of x squared. And in our minus 25y squared, our square of that is 5y. 5y times 5y is 25y squared. So what we have here is the difference of two squares. So how do we factor that? Well, Here's our first term here in parentheses, our second one here. We start off with our x to the fourth here. And we have to determine what times itself equals x to the fourth. Well, x squared times itself equals x to the fourth. So we stick an x squared here and an x squared here. X squared times that x squared gives us our x to the fourth. Now over here in our second term, our second monomial, we have minus 25y squared. Remember, 25 is a square and y squared is also a square. What's the square of 25? Well, it's 5. What's the square of y squared? Well, it's y. So we know we have to have a 5y here. That's a plus. And we have a minus 5y here. Positive 5y times a negative 5y equals a negative 25y squared. So let's double check and see if our answer here is correct. X squared times x squared is x to the fourth. X squared times a minus 5y is minus 5x squared y. Now our positive 5y times x squared here is going to be a positive 5x squared y. And then our last one here is going to be our plus 5y times our minus 5y. That's going to give us a negative 25y squared. This minus 5x squared y and this positive 5x squared y, they cancel. So what's that leave us with? That minus here goes with 25. It leaves us with x to the fourth minus 25y squared, which is in fact what we started with. Lastly, we'll take a look at one other one. 5x squared minus 10. And actually that's a mistake. That should be 5x squared minus 5. At first sight here, this is not the difference of two squares. 5 is not the square of any other integer. But what we can do is we can start by factoring out a common factor to both. We have a coefficient here of 5 and a coefficient here of 5. We can actually factor out a 5. So let's bring the 5 out front. And then we're going to have our parentheses here. 5 times what equals x squared? Well, 5 times x squared equals x squared. 5 times what equals a minus 5? Well, 5 times a minus 1 equals a minus 5. So we've brought the 5 out front, and now we're left with x squared minus 1. The question now is x squared minus 1 the difference of two squares? Well, is x squared the square of something? Yeah, it's the square of x. Is this 1 here the square of something? Sure it is. It's the square of 1. So we actually have the difference of two squares here. And remember from our first statement over here, the difference of two squares is going to be a plus b times a minus b. So in this situation here, we're going to leave our 5 alone. It's not a part of the square. And we're going to break our x squared minus 1 into our two terms here. Our first one we're going to deal with is the x squared. So we're going to put an x here in the first term there in the first slot. And then we're going to put an x here in our first term of our second phrase. That x times the x is going to be our x squared. Then it's simply going to be plus 1 and minus 1. That's it. 5x squared minus 5. By factoring the 5 out, that gives us 5 times x squared minus 1. X squared minus 1 factors to x plus 1 times x minus 1. So 5 times x plus 1 times x minus 1 is the factorization of 5x squared minus 5. And just as a quick review for the difference of two squares, a squared minus b squared factored out is a plus b times a minus b. Okay, that'll finish up session 68 on factoring the difference of two squares.